Graph the trigonometric cosine function y equals 1 minus 2 over 3 cosine of x. We know that this is the transformation of the graph of f of x cosine of x. The first thing it does to the graph of cosine of x is to negate the function, and so the first transformation is negative cosine of x. It then stresses by a factor of 2/3. Y equals negative 2 over 3 cosine of x. And lastly, it takes this graph, negative 2 over 3 cosine of x, and it shifted up 1 unit. And so, to graph y equals 1 minus 2 over 3 cosine of x, we will follow these transformations. For trigonometric functions, most likely we have to scale the x-axis so that it is a multiple of pi. In this case, pi over 2, pi, 3 pi over 2, 2 pi, because the period of cosine is 2 pi. First, we need the graph of cosine of x. Using the 5-point technique, the graph of cosine of x starts with high as y equals 1 because cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. And so the graph of cosine of x is high and then middle and then low and then middle and then back to high. It should be a little bit curvy, but not a straight line here because it is around the unit circle. The first transformation is to negate this or flip this about the x-axis. And so we will take this graph and we flipped it over about the horizontal axis. At x equals to 0, y equals 1. We move it to x equals to 0, y equals negative 1. X equals to 0, y equals to 0 stays at y equals 0. At x equals pi, y equals negative 1 now. We would flip it over, and so at x equals pi, y is now 1. At x equals 3 pi over 2, y is 0, so we can't move it, 0. The reflection of y equals to 0 is 0. And at x2 pi, y equals 1, so we would reflect it down to negative 1. And so the graph of negative cosine of x is now, instead of high, it is starting at low and then go to the middle and then go to high and then go back to the middle and then back to low. The blue graph is the graph of negative cosine of x. Next, the 2/3 in front was shrink the graph by a factor of 2/3. And so if y equals negative 1, shrink it by a factor of 2/3, we will end up with negative 2 over 3. At x equals pi over 2, y equals 0. If we shrink 0, we'll end up with 0. At x equals pi, y equals 1, and 2/3 of 1 is 2/3. And so, at x equals pi, the new y value is 2/3. At x equals 3 pi over 2, y equals 0, and so 2/3 of 0 is 0. And when x equals 2 pi, the y value of the blue graph is negative 1, and we shrinked it by a factor of 2/3, and so the y value is now negative 2/3. Using the 5-point techniques again, we will connect these 5 points to get the graph of negative 2/3 cosine of x. Low to the middle, and then go to high, and then back to the middle, and then go to low. Remember that we only multiplied 2/3 because we took care of the negative already. Next, we will take this yellow graph, which is the graph of negative 2/3 cosine of x, and we shift it up 1 unit. And so, from negative 2/3, we add 1 to this to get to y equals positive 1/3. From y equals 0, we move it up 1 unit, and so now y is 1. From 2/3 at x equal pi, we would move it up 1 unit. 2/3 plus 1 is 5/3. And that is 5/3. From x equal 3 pi over 2, we would move it up 1 unit. It is y equal to 0 now, so move it up 1 unit, y is now 1. And lastly, from negative 2/3, if we add 1 to negative 2/3, we will get 1/3. We end up with the set of 5 new points. And these 5 new points are 1 unit up from the yellow graph. We connect these 5 points to form the graph of negative 2/3 cosine of x plus 1, or 1 minus 2/3 cosine of x. This is a cosine graph, and it looks like it starts at low, go to the middle, and then go to high, and then back to the middle, and then back to low. The final graph is the graph of y equals 1 minus 2/3 cosine of x. The amplitude, by looking at the formula given, it is the coefficient in front of the trig expression, in this case cosine. The coefficient in front of cosine is negative 2/3, but the amplitude is the absolute value. So we will take the absolute value of negative 2/3, which is positive 2/3, and that is the amplitude. The maximum or the highest value from the graph, we see that it is 5/3, and it occurs at x equals pi. X equals pi is not the maximum. The maximum is the y value. And so we say that the maximum of this function is 5/3. And remember, we get 5/3 because we took 2/3 at x equals pi, which was the yellow point, and we add 1 to it. 2/3 plus 3/3 is 5/3. And that is the maximum value of the function. Alternatively, if we don't have the graph, we see that cosine of x is between negative 1 and 1 originally. We then change the middle expression, cosine of x, so that it looks like 1 minus 2/3 cosine of x. The first thing we do is that we multiply all parts to negative 2/3. In the middle, we get negative 2/3 cosine of x. And the last part, we get 1 times negative 2/3. And then the first part is negative 1 times negative 2/3. But in an equality, if we multiply a negative number, we would need to flip the sign, the inequality sign. And so this is now negative 2/3 less than or equal to negative 2/3 cosine of x less than or equal to positive 2/3. And then we still need to add 1 to this. Add 1, add 1, add 1. 1 minus 2/3 is 3 minus 2/3, which is 1/3. Less than or equal to 1 minus 2/3 cosine of x less than or equal to 1 plus 2/3 is 5/3. And so the maximum of 1 minus 2/3 cosine of x is 5/3. If we wanted the minimum value of 1 minus 2/3 cosine of x, it would have been 1/3. This is also known as the range of the function. In this case, the range of the function 1 minus 2/3 cosine of x is from 1/3 to 5/3, including the endpoints. The domain of this function is the set of all real numbers, and so if we want another cycle, we just simply go from 2 pi to 4 pi and copy the exact same graph.